Hey, welcome to today's lesson. Today's lesson is actually where I'm going to introduce something that looks like a new function, but it's really something you're familiar with and you've used quite a bit. And that function is called a logarithm. And logarithms are exponents. That is a big idea of today's, that a logarithm is just an exponent. So to start out, let's actually take a look at this old optical illusion here and think about what do you see when you look at this? So take a step back and think about what it is you're looking at in this picture. And people tend to see two different pictures. Some people see an old woman where this is her eye, and here's another one of her eyes. This is her nose right here, and this is her mouth and her chin. But if you look at it from a different perspective, you might see turned away from you a young woman where this is her nose and her eyelash. This is her ear, this is the outline of her face and chin, and this is a brooch. And today's lesson is all about changing your perspective. We want to look at exponential functions from a new light, from a new perspective. And that perspective is a logarithm. So up to now, we've been looking at exponential functions, exponential equations, where we kind of focus on this end result. So for example, this 2 to the 5th equals 32. We call this 2 the base, and this 5 is the exponent or the power, and this 32 is the result. And in Algebra 1, you probably talked about this base number of 2 as the growth rate, and this 5 as time, the number of times you have that growth rate occur. And then this 32 is the end result, the final result. And so, up to now, your whole focus has been on, what is that final result? And if we throw our vocabulary into the way we set this up, the base number is raised to the exponent, and it gives us a result. We're going to look at things in a different light, though. But let's dig into what's going on, first of all, with exponential functions. So when we look at this problem here, 2 to the 5th equals x, we've always focused on what is that end result. And we've always thought about, okay, 2 to the 5th means 2 times itself 5 times, and that's just 32. And again, our focus has always been on what is 2 to the 5th? What is that end result? But what if we change our focus? What if instead of focusing on the end result, we want to know what that exponent is? So for example, 3 to what power is 27? And we can test this using some logic and some guessing. 3 to the 1st is obviously not 27. So if we repeat the multiplication, which is what an exponent does, 3 times 3, still not 27. 3 times 3 times 3, well, what is that? That's 9 times 3. That is 27. So in this case, what is the exponent? What is the number that represents our growth rate, our time? That's 3. So this is what a new function called logarithms do. That this new function changes the focus away from the end result, and it puts that focus on the exponent. The exponent becomes what we want to concern ourselves with. So the big idea today is just the idea of being fluid in writing our two different forms, in writing something from exponential form into logarithmic form, and going back from logarithmic form to exponential form. It's all about, can we change our perspective and see the same thing, the same idea, two different ways. So in exponential form, one of the things that we need to be able to do is to read this out loud. And this is read 2, my base, to the 5th power, my exponent, is equal to 32, the result. If I rewrite that in logarithmic form, notice that the base of 2 suddenly becomes this subnumber. The result of 32 is the focus of the function. The logarithmic function operates on 32. And what's interesting about exponential functions is when we switch them to logarithmic functions, this exponent of 5 gets to come down and get its own side of the equal sign. And this is read log base 2. Remember, we call this number here the base. Log base 2 of 32 is equal to 5. Now, in exponential form, our focus is on the result. In logarithmic form, our focus is on the exponent itself. And again, being able to go back and forth between these two different forms of the same thing is our focus for today. Can you take something from exponential form and move it to logarithmic, and logarithmic back to exponential? And you're probably wondering, why are we spending our time doing this? And let me give you the big picture. The big picture is we want to be able to solve this equation. 2 to what power is 10? Now, I know some knucklehead is thinking it's 5, but no, we know 2 to the 5th power is 32. We just saw that. But there is a number here that you could raise 2 up to that gives you 10. Now, that number is not a pretty integral number. It's a decimal or a fraction. But we can find it using logarithms. So since logarithms let us focus on the exponent, it takes the focus away from the result and turns it to exponents. They will become the perfect tool to solve this problem. And you're going to see that that's really important when we're dealing with all sorts of things like exponential growth of bacteria, exponential growth of population, or what you're probably most interested in, exponential growth of your money. And so in order to be able to solve all those problems, we've got to be able to change our focus away from the result and up to the exponent. And that's what logarithms help us do. So for now, just today, let's really focus on changing our perspective between exponential notation and logarithmic notation. They both represent the same idea. You're just looking at them in different ways. So again, you're going to want to pause this video and write down examples and solutions so it will help you as you approach problems in the future. So our first goal is I'm going to give you an equation in exponential form, and I want you to switch it to logarithmic form. So for example, 4 to the third is 64. We know 4 times 4 times 4 is 64. And 7 to the 0 is 1. Like, those are two equations that are true, and they're written in exponential form. And all we want to do is change it to logarithmic form. And this right here is the whole key. Up at the top, I have exponential form. We have a number called the base, raised to a power called the exponent, and it gives us a result. And we want to be able to change that to logarithmic form. And logarithmic form is called the logarithm of base. The base goes down here of the result, gives us the exponent. So let's take a look and see how we would make this change. So first of all, this number 4 is the base. When I move it down here to logarithmic form, that 4 becomes the base of the logarithm, like that. 64, our result, becomes the focus of the logarithm. It's what the logarithm is operating on. Log base 4 of 64. And finally, the exponent, which has always been a shrunken number shoved up in a corner, gets to come down and get its own side of the equation. And notice it is a normal number now. And this is read log base 4 of 64 is 3. Now over here, we have another exponential form, and we can rewrite that as a logarithm. The base of this exponential form is 7. And so that 7 becomes the base of my logarithm. The result of this exponential form is 1, and the result becomes what the logarithm is operating on. It is operating on that 1, log base 7 of 1. And finally, the exponent of 0 gets to finally come down. It's no longer a small number shoved in a corner. It's its own number, and it gets its own side of the equal sign. Let's take a look now and see if we can switch and go from exponential to logarithmic form. So here we go. Log base 4 of 64 is 3. Log base 2 of 1/8 is -3. Let's see if we can put these in exponential form. Now most kids, and myself included, look at this logarithm and it's very confusing. Exponential form tends to be the easier form. And let's see if we can switch from this kind of more complicated logarithmic form into the more comfortable exponential form. Again, this is what I want to look at here, except instead of going from the top down, we're going from the bottom up. So I know that my logarithmic base is 4, so that becomes the base of my exponent. So this simply becomes 4 is my base, my exponent is 3, and my result is 64. Now pause the video and see if you can do number 4 on your own. Think about what the base, the result, and the exponent are, and then write it in exponential form. Hey, welcome back. The base of this logarithm is 2, and that's going to become the base of my exponential form. The exponent is -3, and the end result is 1/8. Again, logarithms tend to be a little more difficult to understand than exponents. It's a more difficult perspective. So the better you get at switching between logarithms and exponential forms, the easier this unit's going to be for you. Now there's one more thing I want to look at, and that's if we can kind of convert between exponential and logarithmic forms to make what look to be kind of difficult problems much easier. So let's see if we can fill in the blank. Log base 3 of 81 is equal to what? Well, again, we don't tend to think in exponential, or I'm sorry, in logarithmic form. We tend to think in exponential form. So what we have here is a picture that's a little too complicated for us to think about. But we can switch this and look at this from a different perspective that's more comfortable to us. My base is 3, so I'm going to rewrite this in exponential form using a base of 3. My exponent here is unknown. I don't know what my exponent is, so I'm just going to call it this unknown empty box. And I know my end result is 81. So 3 is the base. The exponent over here is unknown. And my end result is 81. Now let's do some math. I know 3 to the first is not 81, so let's multiply it by itself once. 3 times 3, not 81. Let's do it again. 3 times 3, 9. Times 3, 27. We're still not there. Let's try it again. 3 times 3 is 9. Over here, 3 times 3 is 9. And 9 times 9, that is 81. So what is this exponent going to have to be? It's going to have to be a 4. Logarithms are not always the easiest representation of a function for you to understand. And if you can go from logarithmic form up here to exponential form, it can be a lot easier. And that's the whole focus of your homework tonight, is can you move fluidly back and forth between these two forms? Good luck.